These are some of my favourite questions for a student that's just starting out with integration, because I think it's a fast track way to understand more deeply what integration means. So these aren't full questions. Have a go at this one in your own time. Pause the video if you need to. Is this true or false? Well, I think it's true, because if we just draw a number line, there's minus 3, and if we integrate from minus 3 to minus 2, and then integrate from minus 2 to minus 1, as we did here and here, then that's the same as if we do this one, which is integrating all the way in one jump. Next question. Given that the integral from 1 to 3 is 17, what is the integral from 3 to 1? You kind of know this or you don't. The answer is minus 17. Because when we go in the other direction, you can think about the maths. The minus sign from the definite integration is going to be on the other term, and the one that did have a minus will have a plus, so it's obviously the negative. And also it's just to do with the fundamental definition of integration. Anyway, let's look at the next one. By the way, note what I say at the bottom. The function being integrated is always positive for this question. Can you work out the integral from 0 to 4? Well, I guess that would be the integral from 0 to 1 plus... let's draw a number line, shall we? So there's a 0, there's a 1, 2, 3, 4, minus 1, minus 2, minus 3. So I know that if I integrate from here to here, I get 10. I know that if I integrate from here to here, I get 2. And I know that if I integrate from here to here, I get 35. That means I can deduce that from here to here must be 8, because it's 10 minus 2. And then that means I can deduce that from here to here must be 27, because of the 35 and the 8. So the answer is, let's just write 27. Let's look at the next question. Oh, I like this question. Let's number line it. Minus 10 to 3 and 2. Oh, they're saying that that is the positive version of this, or the other way around. Doesn't matter. Anyway, the point is the 2 must cancel out, and therefore the answer is 0. If I drew a graph of that, maybe the graph would look like that. No, hang on, that's not very good. Let's try again. Maybe the graph would look like that. So you've got a massive positive bit there, maybe, and a similarly sized negative there. Hopefully that makes sense. We're going to do another question that will help understand that. Is it true that a must be 5? Well, no, it isn't, because maybe the integral from minus 11 to minus 6 just happens to be the same. Yeah, so this, do you remember I said we're going to do another question which will help you understand the previous one? This is it. Without calculation, state the answer to this integral. And the answer is 0. So this one is easier to explain. So I'll save you my explanation for here. That's what y equals x cubed looks like. And let's say that's 2 and that's minus 2. By the way, this is the last question, so if you've got everything, you can move on to your next bit of learning. You can skip the rest of this video. That area, by symmetry, has to be exactly the same as that area. And when you integrate, let's say that's 1, I don't know. Let's say that's 1. In which case that'll be minus 1. So they have to cancel because they're symmetrical and exactly the same size, but when you integrate, if something's below the axis, it's negative. There we go. Thanks for watching. Hopefully that was helpful.